The lesson topic for this video is logarithmic functions. All right, so we are going to talk about a way of solving an equation in a method that you've never actually probably seen before. Let's think for just a minute about this equation. 2 to the x power equals 8. If we were supposed to solve for x right now, I think most of you could figure out what it is. 2 to what power is equal to 8? Well, 2 to the first is 2. 2 to the second is 2 times 2, which is 4. And 2 to the third is 2 times 2 times 2, which is, in fact, 8. So you would know in this case that x equals 3. But what if I asked you, let's see, 3 to what power is 1,262.665. Well, that probably seems a little bit trickier because we wouldn't want to just guess and check what I'd raise 3 to get to that number. 3 to the first is 3, 3 to the second, 3 times 3 is 9, 3 to the third is 27, 3 to the fourth is 81. We're getting closer, obviously, but it would be kind of annoying to try to just guess and check and figure this out. So instead, we use something called a log, because a logarithmic function is the inverse of an exponential function. And let me talk briefly about what I mean by that as well. I'm going to take a little space over here. You guys, if it was 3 times x equals 12, we know that we would have to do the inverse operation. This is being multiplied, so we would divide both sides by 3. Right? To solve for x equals 4. Or if we had x to the third power equals 12, we know that we would do the inverse operation of, instead of raising it to the third power, we would square root. Or in fact, this would be, cube root. We'd cube root both sides to find out what x is, because those are inverse operations. So we would use the inverse operation of an exponential function. This is an exponential situation because the variable's in the exponent, but we would need to use the inverse of that, which is using a log. So let me show you what that means on the next screen. All right, so for this example, I'm going to use 3 to the x power equals 81. Okay, so this one, and we already talked about it on the previous screen, you could guess and check right now. You could say 3 to what power will give me 81? Well, 3 to the first, 3 to the second, third, fourth, you might already know what it is. But I want to show you how we can figure that out. And you might want to have your calculator handy for this. So 3 to the x power equals 81 can be rewritten as a log by, well, we start by writing the word log. And then we always write the base for the log, and we need to write the base right here. Now the base, if you think back to when you learned about power rules earlier in your life or exponent situations, this was the base, 5 is the base, and 2 is the exponent for this power, right? Base, exponent. So what's the base over here? Well, the base is 3. So we're going to say log base 3 of 81. Okay, so we bring this over to here, equals that exponent, x. Log base 3 of 81 equals x. Now, I had actually said grab your calculator. Now that I think about it, in this lesson we're actually not going to compute what log base 3 of 81 is, because your calculator only does what is called log base 10. Now, since this is not base 10, we can't use our calculator right now to compute this answer. All right, we will get back to computing these when we learn something called the change of base rule later in a later lesson. So if you grabbed your calculator, great, but you're not going to need it, and I'm sorry about that. So here's the deal. This right here and this right here mean the same thing. And we'll be able to learn a way to compute this. We can find the value of our exponent for any problem of this sort. So here's the deal down here. Let's start by looking at this right here. A to the y power equals x, right? The base is a, the exponent is y, and the answer is x in this situation down here. So that's just like we were saying here. Base of 3, exponent is x, equals 81. this is the same as this. Again, we write log base A, because A is our base, of this value over here is equal to the exponent. So again, remember, a log is an exponent. A log is an exponent. That's how we solve when our variable is in the exponent. So for this chart, we're just going to practice going from one form to the other. You'll notice right here, the base is 3 raised to the second power equals 9. So we write log base 3 of 9, this number right here, is equal to the exponent 2. Right here, 5 raised to the third equals 125. So log base of 5 of this number right here is equal to our exponent, which is 3. So let's do this one now. 2 to the fourth power equals 16. So log the base of the power right here, the base is 2, of the number, which is 16, is equal to the exponent, which is 4. Okay, what if we had to go the other way? So these, we're going the other way, we're going to write the exponential form. If I have log base 25 of 625 equals 2, remember that 2 is our exponent and this is our base. So we would write 25 raised to the second, because that's our exponent, equals 625. And we hopefully all know that 25, when squared, is indeed 625. So again, log base 25 of 625 equals 2. So 25 raised to the second power is this. Okay, fill that one in. Okay, hopefully you noticed this is one I was doing on the previous screen. The base is 3, the exponent is 4, and it equals 81. So 3 to the fourth power equals 81. Okay, the next one, 5 to the x power equals 3,125. So we write log. Our base is 5 of what number? 3,125 is equal to our exponent, which is x. Why don't you pause the video and try these next two? I know they don't have numbers, they have variables, but you can still use the same rule and fill those two spots in. Then check back to see how you did. All right, so hopefully you wrote log base A of the number c is equal to our exponent, which is x. And the very last one, since it's already in log form, we need to start by writing our base. Our base is b. Our exponent is c, because it's right here. Exponent is always what it equals, and that equals x. Okay, so on this screen we have some examples of actually evaluating our logs, and we're going to run through a few examples together, and then I'll have you try a couple on your own. So first of one, say evaluate without a calculator. Log base 2 of 4. If it helps at all, you can write equals and then a variable of your choosing, for example x, if that makes you more comfortable, which it probably will, because what we're going to do is we are going to rewrite this with our base. Well, our base is 2. Our exponent is x, because our exponent is always what the log equals, and that equals 4. So you guys, 2 to what power equals 4? Well, the answer there is 2. 2 to the second power is 4. All right, the next one. Base of 10 raised to what power? X equals what? 10,000. All right, so what do we have to raise 10 to get to 10,000? And that would be 4. So 4 is our answer for that one. Log base 10 of 10,000 is 4, because 10 times 10 is 100, times another 10 is 1,000, times another 10 is 10,000. All right, this one here. Okay, what is our base? Our base is 0.2. Raised to what power? X equals 125. Now, what are we going to do to figure out what 0.2 is being raised to get to the to get to 125? Well, this one's actually a little bit of a challenge problem, and if you don't fully understand this one, that is okay. But let's think about 2 as being 1 over 5, right? 0.2 is 1 over 5. So now we have 1 over 5 equals 100, raised to the x power equals 125. Well, think about how if we are going from a fraction raised to a power and we get a 125, a larger number here, this will have to be raised to a negative value because somehow we need this 5 to come up to the numerator. And if you remember, a negative exponent is how we get a number moved from the bottom of a fraction to the top or vice versa. So if I know that it's going to end up being 5, sorry about that, 5 raised to some negative power to get to 125, okay, well, what negative power would we need? Well, 5 times 5 is 25, and 25 times another 5 is 125. So 5 to the negative 3 power is 125. Again, this one was a little bit on the challenging side. Maybe I didn't need to go there on the first lesson, but x will equal negative 3. All right, so let's look at these other ones. Evaluate the log. X equals log base 3 of 81. Well, again, we're going to rewrite this because we can't compute this with our calculator right now, okay? Because our calculators are in log base 10. All right, so we're going to write the base as 3 raised to the x power, the exponent, is equal to 81. Well, you guys, 3 to what power is 81? I think we did this one a couple times now on this video, so it's 4. 3 to the 4th power is 3 times 3 times 3 times 3, which is 81. Okay, this next one, log base 5 of 25 equals x. The base is 5. The exponent is x, and it equals 25. What does x need to be here? Well, 2. X to the second power is 5 to the second power is 5 times 5, which is 25. The next one. The base is 8. The exponent is x, and it equals 1. Oh, this is a good one. You guys, 8 to what power equals 1? Well, anything raised to the 0th power is 1. So this one is x equals 0. All right, the next one. We have our base of x, so we're going to write the base of x, and we're going to raise it to the exponent power, which is 3, and it equals 1,000. So this one ends up being a little bit different, but we can find out what x is when we raise it to the 3rd power and we get 1,000. What number raised to the 3rd is 1,000? Well, that answer is 10. 10 times 10 is 100, times another 10 is 1,000. So this just helps us write them and then solve. All right, this one has a base of 64, power of 1/2, and it's going to equal x. Well, this is something you might not have seen for a while, but raising to a 1/2 power is the same as taking the square root. So what's the square root of 64? Well, it is 8. And our last one here. 4 is the base, raised to the what power? 4 is equal to what? X. Well, 4 to the 4th power. 4 times 4 is 16, times another 4, times another 4. 4 to the 4th power is 256. Sorry about that. Okay, and I only have about 10 seconds for this, so a couple terms. Common log. A common log is when there's a base 10. That's what we call the common log. When there is no base written in, we assume it is a 10, which makes it a common log. So these are the same. The natural log we're not going to use, but I wanted to show that these are, you're going to see this on your calculator as well, the ln, and we're not going to be using that. All for now.